All right, we look at these three functions, and the question is, can we take the derivative of them? Can we find the tangent slope generator of them? And j of x here, 2x squared plus 3 squared, you know we can distribute this one first and then take the derivative, no problem. But h of x and k of x, we have problems. H of x is a problem because I do not want to take this to the 5th power. It would take me a long time to distribute, a long time. K of x, I can't simplify in any way. I can't rewrite this as the square root of 4x, 5x to the 4th plus the square root of 3. That's not true. So we need a new rule for these types of functions, okay? Now the key to all of these functions is that they are all compositions of functions. I don't want to just say two functions. We'll say they're compositions of functions. What do I mean by a composition? We have like a function on the inside and a function on the outside. Like j of x has an outside function, which is like these parentheses squared. It's like x squared. And the inside is the 2x squared plus 3. Okay, the h has stuff being taken to the 5th power, and then we have all the stuff inside of that. The k has the square root on the outside, and then the stuff on the inside. Okay, now we need a way to be able to take the derivative of these compositions. Okay, and this is where we have the chain rule. So we're going to be taking the derivative of a composition. I'm going to say it's f as the outside and g as the inside. Okay, first thing we're going to do is make sure we denote what the outside function is and what the inside function is. I'm going to say the outside is f of stuff. I'll say stuff a lot. You could say it's f of, x, but I don't want that to confuse you. But we can think of it as having an x inside of it. And then the inside would be the g of x. What we're going to do is take the derivative of the outside and the inside, and then just multiply them together. The derivative of f, I'll say, is f prime. The derivative of g is g prime of x. Multiply these two, and you'll have the correct derivative. So I'm going to say this is equal to f prime times g prime of x. However, we're not going to want to have just like this blank space after f prime. That's not going to make sense. So what we're going to do is just understand that what was inside of f was g. We're just going to leave that inside of f prime. So it's really the derivative of the outside with the inside left alone times the derivative of the inside. Okay? But how we'll go through each problem is we'll just focus on the outside, inside, take the derivatives, multiply, and then fill in kind of the blank stuff later. So let's look at taking the derivatives of these three using the chain rule. Starting with j, understanding that its derivative is 16x cubed plus 24x. Let's see if I can take this derivative using the chain rule. Okay? So for j, I'm going to first designate it as an outside and an inside. And I'm going to say the outside function is the stuff being squared. Those parentheses to the 2nd power, that's like the outside function. The inside function would be the 2x squared plus 3. Now, if I went ahead and take those derivatives, I would assume this is like a x being squared. So pretend like there's an x there. The derivative of x squared is 2x. So I'm going to say that the derivative of the stuff being squared is 2 times my stuff. then the derivative of the inside is 4x plus 3. Okay? Now all I need to do is multiply those two together, and I will have j prime. So j prime is equal to, whoa, I don't know why I put that, sorry, is just 4x. So j prime is just the product of the derivative of the outside and the derivative of the inside. So I'll just have it as 2 times some stuff times 4x. However, I'm going to go ahead and say, okay, what started out inside the stuff being squared? It was this 2x plus 3. It was this inner stuff. So that's going to go in here. Now let's go ahead and check. Is that equal to 16x cubed plus 24x? Well, if I multiply the 2 and the 4x, I got 8x. 8x times 2x squared plus 3 will give me 16x cubed plus 24x, which is exactly what we had after distributing. What you will find is that it's probably easier to take the derivative of this using the chain rule rather than having to distribute. So this is going to be a very, very valuable tool that we can use. Okay, let's go ahead and you guys try H while I do it. See if you can understand and list off the outside, the outer function and the inner function. Take their derivatives and then just multiply those together and fill in the blanks. Okay, I should get 5 times 4x cubed minus 3x squared plus 2x to the fourth times 12x squared minus 6x plus 2. Okay, let's do k. It's pretty cool that like this crazy complicated function, its derivative is actually simple to find. Its tangent slope generator is not super difficult to get to. And if you plug in values into this, you're going to get tangent slopes of that, instantaneous rates of change of that. Okay, try with k. Okay. If you want to simplify this, you can. 10x cubed over the square root of 5x to the fourth plus 3. Just a notation simplification. Do the next one on your paper. It should be easy. Check their answer with a neighbor. Let's make sure we are on top of these simple ones where we can see we have powers as our outside function. We won't always have powers. Okay, check your answer with a neighbor for the derivative of this. Okay, simple. 3x squared minus 2x plus 1 squared times 6x minus 2. Not super bad. They get a little bit more difficult when we involve multiple rules. Okay, so this one we see we have x squared times 2x cubed minus 3 to the fourth power. Very, very important when you see these, not to just think, oh, chain rule. And a lot of students will say, oh, the outside is x squared times this to the fourth, and the inside is 2x cubed minus 3. And it might work out if you do it that way, but usually they're not going to do it that way. So don't immediately jump to the chain rule. Instead, notice that this is a product. So I need to use the product rule. Okay? So let's at least start it off. I have the derivative of the first, that's 2x, times the second, 2x cubed minus 3 to the fourth. This is the derivative of x squared times the second. Plus, now we need to take the derivative of the second piece. This is when we will use the chain rule. So let's just go ahead and I'll do that up here. I have an out, which is my stuff to the fourth power. I have an in, which is the 2x cubed minus 3. The derivative of the out will be 4 cubed. The derivative of the in will be 6x squared. So multiplying those together and filling in the gaps, we'll have the derivative of the second piece. 4 stuff cubed times 6x squared. Fill in what the inside is. The inside was the 2x cubed minus 3. Okay, now that is the derivative of the second piece. Don't forget to multiply that by the first piece. A lot of students forget after they take the derivative using the chain rule of that second piece to include the first piece. Okay, so we need to be careful there. Now this is the correct derivative. This is great. However, many times I will see a problem like this on an AP test, and you guys will get the correct derivative like this, but you look at the answer choices and you don't see this in any answer choice, which requires you to be able to simplify this. Okay? And what you will see applications are y primes equaling products. Okay, this is a sum. How do I make a sum of products? I need to factor some things out. Now, notice that you have two terms. This is one term. This is our second term. We'd like to factor out what those two terms have in common. Well, I notice this has a 2x, and I can pull a 2 and an x out of there. So that's one thing that they have in common. I also know that they have 2x cubed minus 3's. This has 4 of them, and this has 3 of them. So I can factor out 3 from both of them. So I notice what they have in common, and then I realize, okay, to simplify this, I'm going to have to factor out 2x times 2x cubed minus 3 cubed. And again, think about dividing when you're factoring. You're dividing out these terms so that the rest is like a product of that, gives you your original. Okay, so I factor out 2x cubed minus 3 cubed. Let's talk about what's left over from the first term. Well, this 2x is gone. 3 of these 2x cubed minus 3 to the fourths are gone, so I just have 1 remaining. Plus, I factor out a 2, I factor out an x, I would have just a 2 left over times the 6, which is a 12. I'd have 1x and 2 x's, x cubed, and that's it. The 2x cubed minus 3 cubes are gone, so this is all I have remaining from the second term. Then we can simplify again, giving us 14x cubed minus 3. This is correct, sure. This is what you're going to see on a multiple choice. And I'm going to ask you to do that on a quiz for next class. This would be able to simplify something so it's a product like that. You all right, Mr. Gilmore? All right, good. That was a pretty funny thing you were doing just now. Okay, cool. Any questions about that? All right, so that's multiple rules. Sometimes you'll have a quotient rule as well. That's when it gets, nasty and doesn't look good. Just be careful and use your rules the correct way. Now, we will typically see the chain rule involved with trig functions and compositions of trig functions. And it's very, very important for us to understand, how these two terms are different. The sine squared of x is different from sine of x squared. The difference is where you would place parentheses if you rewrote them using them. Sine squared means we are taking all of the sine of x and squaring it. Sine of x squared means I'm going to be squaring x, then taking the sine of it. This is important because if we are going to take the derivative of these, we have two different outsides and insides. For sine x squared, the outside would be the squared, the inside would be the sine of x. But for sine of x squared, the outside is now a trig function, which we are not used to yet, but now we see it. And the inside is the x squared. Okay, so taking the derivative of the first guy, I would 2 to the first and cosine, giving me y prime of sine squared is 2 times cosine of x. fill in the inside. The inside is just the sine. But for this guy, the derivative of the outside is cosine. The derivative of sine is cosine. The derivative of x squared is 2x. So this guy would be cos of times 2x. Fill in the inside, x squared. Okay? Now let's go ahead and take the derivative of these two. However, since you do not know the derivatives of secant and tangent just yet, let's use sine and cosine. So let's do cosine cubed of x, and let's do sine of x to the fifth. Go ahead and find those derivatives. My recommendation is that if there isn't parentheses or if the parentheses are misleading, rewrite using parentheses. I would rewrite this first one as the cosine of x cubed. I could keep the parentheses around that x, but we know it's just the cosine of x, so it's not necessary to have the parentheses around the x. So those are a little bit misleading, but it's the cube that can be taken out. This is already set up for you to understand the outside and the inside. Now, eventually you'll be able to use this procedure and do it all at once without having to, write down the outside and the inside. And if you want to try it on your homework to just, write down the derivatives, go for it. Because eventually we'll be doing this enough that you'll know that it's going to be cosine of x to the fifth times 5x to the fourth. And here you're just going to see it and you're going to be 3 cosine x squared times negative sine x. But until we're there, make sure you are showing all these steps, okay? Second one, we should get cosine of times 5x to the fourth. Fill in the inside. The inside is the x to the fifth. Okay? Now, they can get harder because we could have a composition of more than 2 functions. We could have a composition of 3 functions or 4 functions or 5 functions. Okay? Now, notice what's going on here. I'm going to go ahead and rewrite this using parentheses. I'm going to write this as sine of 4t squared cubed. Okay? Well, this has an outside, which is the stuff being cubed. But if I say the inside is the sine of 4t squared, notice this is still a composition. So actually, I'm going to say I have an outside, a middle, and then an inside of the 4t squared. So I actually have a composition of 3 functions. So I'll just get rid of that. So we work outside to inside. Now, just like we did with 2 functions, we're going to do it 3 functions. I'm not going to show you using f of g of h. I'm just going to show you how you would do it here with this example. Just like we did, we would take the derivative of each of my pieces. This is 3 stuff squared. This is cosine of stuff. And this is 8t. Well, our derivative would be multiplying this to this to this. Just making sure that what's inside is correct. Okay, so let me just write out what the derivative looks like. It's 3 stuff squared times cosine of stuff times 8t. Right, that's simple. Just work outside to inside. Multiply the derivatives of each of the pieces. Now, what is going inside of these pieces? Well, the sine is going into the stuff being cubed. So sure, I can write down sine, but it's the sine of stuff. What is the stuff that's in sine? It's the 4t squared. Then, when I took the derivative of the sine, I got the cosine. This would be the 4t squared in there. So you see, it's the stuff that started out inside the cubed, that gets left in there. The stuff that started out inside the sine, that gets left there, followed by the 8t. Go ahead and do this. 1. I'll get rid of the 1/4. Actually, whatever, keep the 1/4. Who cares? Go ahead and try it. Did you write it as a composition of 4 things? Because it is. 1/4 squared, then sine, then fifth, then 3x plus 2. What would that derivative look like? Well, wouldn't be pretty. It'd be nice and long, but it would be correct. It would be 1/2 cosine 5 to the 4th times 3. Let's fill in the gaps. It'd be sine of 3x squared to the 5th. Or 3x plus 2 to the 5th. Times the cosine of 3x plus 2 to the 5th. Times 5 times 3x plus 2. Times 3. Okay? That's it's a little overkill. At most, you'll see 3 functions being composed that you'll have to take the derivative of it. So just make sure you identify the outside, the middle, and the inside. Okay? Now, do you have any space here? Good. On the bottom, the chain rule is actually going to help us with some functions. You're going to just write this in, guys. With some functions that we would have to use the quotient rule to find the derivative of. Okay? So like if I ask you to take the derivative of 1 over x plus 2, you're thinking quotient rule. But let me show you there's another way. It might be easier. Okay? So I want to find the instantaneous rate of change of this function at 1, so I'm going to have to take the derivative. Watch what I can do. I can put this denominator in parentheses and take it to the negative first power. And I can rewrite this, sorry, to the first power. Oops, I worked ahead of myself. To the first power. And I could rewrite this as just x plus 2 to the negative first power. Now, I don't have to use the quotient rule. I can use the chain rule. The derivative, I'm going to do this quickly, would be negative 1 x plus 2 to the negative second times the derivative of the inside, which is just 1. So this is an easy way to see that this derivative of 1 over x plus 2 is negative 1 over x plus 2 squared. Okay? So this guy, let's say this is negative 3 over 3x squared plus 2 cubed. I wouldn't use the quotient rule because I'd have to use the quotient rule and the chain rule. Instead, I would rewrite this as negative 3 times 3x squared plus 2 to the negative third, and then take the derivative. I'm going to do this all at once and see if you can follow along. So it would be positive 9, 3x plus 2 to the negative fourth times 6x. Okay? That's it. Hope you understand the chain rule. Questions, come see me. Homework's out of the book. Last lesson, next class, test next Wednesday.
On the 5, 3x plus 2 to the 5th. Like, you know, you click on the inside to the 3x plus 2 to the 5th on each side.
Except for this one?
Yeah.
Because this is the 5. The derivative is 5 to the 4th.
You don't have to put the same inside?
No, the inside is this piece goes in here. Okay. Both of these pieces go in here. All 3 of these pieces go in there. See how that works out? You just kind of, this goes here. But it's really, that goes there. Both of these go there. All 3 of these go there. Okay?
How long do you think it takes to grade every test?
I'll have it done by this afternoon.